In this video, I will show you how to write a standard form equation of one of our four conic sections given a variety of pieces of information. The four conic sections I'm referring to: circle, ellipse, parabola, and hyperbola. Well, for number 11, we're given a focus and a directrix. There's only one of the shapes that has a directrix, and that is a parabola. So let's sketch what we have. So let's see, over here I'm going to make an x and y axis for my sketch. Okay, we have a focus at -1, 4. So here's -1, and then 1, 2, 3, 4. Okay, so I have a focus right here at -1, 4. We have a directrix at x equals 3. X equals a number is a vertical line. So we're talking about a vertical line at 3. So that would be like right here. Okay, now we know that the vertex of the parabola should be midway between the focus and the directrix. So these are 4 apart. So if I go, for example, 2 away from the directrix, which also puts me 2 away from the focus, that's where my vertex should be. So obviously the parabola has to be wrapping around the focus in this direction. This is important because we have a horizontal parabola. I know that whenever I have a horizontal parabola, the model that we use is the one that has the y squared. So y minus k squared is equal to 4p times x minus h. This is the model that we use when it's sideways. If it's vertical, then the x minus h is over here and the y minus k is over there. Anyway, the h and the k are the coordinates of the vertex, which is right here. So what are the coordinates of this vertex anyway? This is the point 1, 4. So this is my h and my k. So they're going to go in here and here. Okay, the y coordinate of the vertex goes in the y part of the equation, and they sort of turn opposite, so both of these are positive right now. So in the equation I'm going to have a minus. So y minus 4 squared is equal to 4p times x minus 1 not squared. Okay, so here comes my equation. All I need is the p value. Well, the p value is the distance from the vertex to the focus. Alright, that arrow I just drew represents the p value. Now the distance is 2. However, see how it's going to the left from the vertex to the focus? That means that p is -2. If it's going to the right, it's positive. If it's going to the left, it's negative. So if I substitute in -2 right here, alright, my equation becomes y minus 4 squared. 4 times -2 is -8. So I have -8 times x minus 1. So this is the standard form equation of the parabola with these characteristics. In number 12, we are told that there's a horizontal transverse axis and an asymptote of y plus 1 equals 2/3 x minus 5. Only one of the 4 conic sections has an asymptote, and that is a hyperbola. A horizontal hyperbola has the x part of the equation first. So the model that we're going to use is x minus h squared over something minus, and then y minus k squared over something is equal to 1. Alright, and this will be a squared and b squared. We'll figure that out in a moment. Now, the h and the k represent the coordinates of the center. But guess what? This is also y minus k. And this is also x minus h. So I can borrow these and use them in my standard form equation. So this x minus h over here is really the x minus 5 that I see in the asymptote equation. This y minus k over here is really the y plus 1 that I see in the asymptote equation. So boom! Now I just need to find my a squared and my b squared. I'm going to use the slope to help me find this. Okay, this is the slope of the asymptote. Now we have learned that when you're graphing the hyperbola, there's a rectangle that's formed. Okay, and the way the rectangle is formed is, look, you've got your center in the middle of the rectangle, and you've got your a value and your b value. Okay, and one of them is going to go like this. All right, that could be your a value or your b value, and one of them is going to go like this. So one of these is your a value and one of these is your b value. It doesn't really matter which one is which right now. Here's what matters. The asymptote that we're talking about goes through these diagonals. Okay, so we are told that the slope is 2/3. That means the rise is 2 and the run is 3. So these are like my a and my b. But in these positions, what we have is a squared and b squared. So if I square this, I'm going to get 9. If I square this, I'm going to get 4. So my denominators will be 9 and 4. All right, I'm just squaring each of these. So all that matters is, if I want to know which one goes in which denominator, well, look which one is horizontal and which one's vertical. The horizontal one belongs with the x. The vertical one belongs with the y, because, you know, x direction, y direction. So the 9 came from the horizontal, so the 9 belongs with the x. The 4 came from the vertical, so that belongs with the y. So that's it. This is my standard form equation of the hyperbola. Number 13, we're given a pair of vertices and a pair of foci. There are two shapes that have a pair of vertices and a pair of foci. We could be talking about a hyperbola, which has two vertices and two foci, or we could be talking about an ellipse. That looks like a face. I'm sorry. Stop it, Burton. We could be talking about an ellipse that has two vertices, like here and here, and two foci, like here and here. So at this second, I don't know which one it's going to be, but watch out for the signs. Your best bet is to draw yourself a nice sketch. So let's see, 7, 3. What's up? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. Okay, so we have a vertex at 7, 3. Okay, we have another vertex at 7, -3. Okay, so whatever shape it is, it's vertical. That tells me something. Now, remember that my vertices are red. Maybe I'll put a red box around them to remind us. I'm going to do my foci in green. So let's see, we have 7, 4, and 7, negative 4. So it looks like I just need an extra little mark. Okay, so my foci are above and below. So if my vertices are red and my foci are green, is this an ellipse or a hyperbola? I'm hoping you can tell right now that this is a hyperbola because the branches, if this is a vertex, then it has to be wrapping around the focus like this. Alright, the branches must wrap around the foci, so it's a hyperbola. Okay, so the fact that it's a hyperbola and it's vertical, that tells us which model to use. Vertical hyperbola has the y term first. So I know I'm going to have y minus k squared, and a hyperbola has the minus. And then I'm going to have my x minus h squared equals 1. So I know this so far. The h and the k are the coordinates of the center. The center is right here. All right, I'm seeing the symmetry. We're 3 up, we're 3 down. The center is going to be right here in the middle, of course. And the coordinates are 7, 0. So this is my h and my k. All right, so my h is 7. So the 7 goes here and the 0 goes over there. So if I make that modification, okay, the x value goes with the x. Alright, and I sort of do the opposite. So x minus 7. The 0 goes here, but don't be silly. We're not going to write y minus 0 squared, are we? No. We're just going to write y squared. Okay, without the minus 0 part. So we have the numerator done. Now we just need the denominators. Now the denominators are the a squared and the b squared. And really I can say that the for a hyperbola the a squared always goes first. Alright, it's always in the positive term. And the b squared is always second. It's always the negative term. Okay, now the a value is always going to be the distance from the center to a vertex. So this is the a value right here. Okay, so let's see. This is the vertex is at 7, 3. So this is 3. So my a value is 3, which means that a squared is 9. So I know that this denominator is going to be 9. Okay, notice also that this is vertical. That's the y direction. So of course it goes in the y denominator. But what about the b squared? The b value is nowhere in the picture. However, what I can figure out is the c value. And indirectly I can use that to get b squared. So they gave us the focus, and maybe I should write down the coordinates of the focus again. 7, 4 is the focus. The c value is the distance from the center to the focus. So that means that my c value is 4. Okay, 7, 4. See it? So my c value is 4, which means that c squared is 16. Now what I really need is b squared. So how is this going to help me? For a hyperbola, we know that c squared is equal to a squared plus b squared. See how the signs are opposite? That might help you remember. Anyway, if c squared is 16, alright, we already know that. A squared is 9. Okay, we know that. And what we want is b squared. So all we need to do is subtract 9 from both sides. So that's going to give us that b squared is 7. You might be tempted to take the square root or something, but don't. What we want is b squared, so don't take the square root. Just put the 7. And that's it. This is the standard form equation of the hyperbola that has these characteristics. In problem number 14, we are told that the major axis length is 10 and we're given a pair of foci. You should already know what shape we're dealing with. The only shape that has a major axis is an ellipse. Okay, picture a horizontal ellipse. I'm not sure if this one's horizontal or vertical yet. But the major axis is the length from vertex to vertex. Okay, it's sort of like you know about the diameter of a circle. Well, we can't call this the diameter because it's not the same in other directions, but we'll call it the major axis from vertex to vertex. Okay, so that is the major axis. Okay, the minor axis is from side to side the short way. Now this is the center right here. So this is the minor axis. Okay, so keep that in mind as we do this problem. Your best bet is to do a sketch whenever you have a problem like this. So here comes my sketch. 2, 2. Okay, I always do my foci in green for some reason. So here's a focus right there at 2, 2. -6, 2 is another focus. Okay, so I have a focus right here at -6, 2. So I know we are dealing with a horizontal ellipse. Now the major axis length is 10. So so far, look, if I drew a segment connecting these foci, how long is that? -6 to 2, that's 8. So that's length 8 so far. So the major axis is 2 more than this. So if I want to get to the vertices, I need to go 1 more unit in each direction. Okay, so I need to go an extra unit. I need to go to 3, and I need to go to -7 for my vertices. So I'm going to have vertices here and here. Okay, so bam, now I have a major, so I had 8 and then 9, 10. So from vertex to vertex, I now have 10. So this is good. So I have a horizontal ellipse. Let's get started setting up the model. Because it is horizontal, well, look, no matter what, when I write the equation of an ellipse, I always start off with the x part. So I'm thinking x minus h squared over something plus y minus k squared over something is equal to 1. This is the model that we always use. So the next thing I need, though, is the center, because that's the h and the k. So where's the center? From the -6 to the 2, that was 8. So how about if I just go over 4? That should be halfway. So 1, 2, 3, 4 should be right here at the point -2, 2. That should be right in the middle. 1, 2, 3, 4. Yes. So -2, 2, that's the center. So this is my h and my k. and I'm going to put those values into my equation. Notice that when I put them into the equation, it's sort of like the signs are going to change. So this -2 will become x plus 2 in the parentheses. This positive 2 will be y minus 2 in the parentheses. So I've got that. Now all I need is my a squared and my b squared. So the a value is the distance from the center to a vertex. Okay, that red line I just drew, that arrow, that is the a value. Alright, so this is from -2 to 3. So that's a total of 5. So my a value is 5, which means that a squared is 25. So this is going to be one of my denominators, but which one? Well, notice that this is horizontal. This is the x direction. So the 25 needs to go in with the x term. So the 25 will go right here. Now I need the b squared, which is the b value is the distance to a covertex, but they didn't give us that. They gave us foci. So I'm going to have to use what I've got. So check this out. I have my a value, and which gave me a squared. Because of having a focus, I can find the c value. The c value is the distance from the center to a focus. So this is from -2 to +2. That's 4. So c is equal to 4, which means that c squared is equal to 16. Now, c squared does not show up here. I need b squared. But I can now use my equation. C squared is equal to a squared minus b squared. That's the relationship. Notice when this is plus, this is minus. So I know that c squared is 16. I know that a squared is 25. So all I need is b squared. So if I add b squared to both sides and subtract 16 from both sides, I'm going to get b squared is equal to 25 minus 16. So b squared is equal to 9. I'm not going to take the square root because this is b squared. B squared is what I want. So 9 goes right here, and that is it. This is my standard form equation of the ellipse with these characteristics. For number 15, we are given 2 vertices and 2 foci. This could be an ellipse or a hyperbola. I don't know yet. Let's make a sketch. Okay, 5, 1. 1, 2, 3, 4, 5, 1. Okay, this is a vertex. So I always do my vertices in red. Okay, -3, 1. Okay, that is another vertex. Now for the foci, which I always do in green. 6, 1. And -4, 1. Okay, so my foci are happening here in green right now. Now, if the foci are outside of the vertices, this must be a hyperbola. I mean, I can just picture it, can't you? If these are the vertices, then the branches have to wrap themselves around the foci like this. So I have a horizontal hyperbola happening. So that tells me a lot of information as far as making this equation. So hyperbola, if it's horizontal, like this one, the x term goes first. So I'm going to start off with x minus h squared over something. For a hyperbola, it's always minus. And then we will do the y minus k squared. And then equals 1. So we're going to start off with this. Later we'll find the a squared and b squared that go in the denominator. But first, the center. The h and the k are the coordinates of the center. I can figure out what that is right now. Let's see. These vertices. This one is 3 to the left. This is 5 to the right. That's a total of 8. So if I go 4 away, that should be in the middle. So 1, 2, 3, 4. So this should be the center right here at 1, 1. That's the center. So that's my h and my k. Okay, so that's why I'm going to have x minus 1 and y minus 1. So now all I need is my a squared and my b squared. The a value is the distance from the center to a vertex. So this is the a value right here in blue. All right, that's the a value. And that is 4. So a is equal to 4. That means a squared is equal to 16. That's one of my denominators. Which one? Notice that this is horizontal, the x direction. So the 16 is going to go with the x term. Okay. Now I need the b squared value. Well, they didn't give me any covertices, so I cannot directly know the b value. But what I do know is the c value. The c value is the distance from the center to a focus. Okay, this green arrow is the c value. 1 to 6, you say? That's 5. So c is 5, which means c squared is 25. I can use these two to find b squared. We know that c squared is equal to a squared plus b squared for hyperbolas. Notice that these signs are the opposite of each other. So we know that c squared is 25, a squared is 16, and we're looking for b squared. So of course we need to subtract 16 from both sides. So b squared is 9. Don't take the square root, we want b squared. So we put the 9. And that's it. This is the standard form equation of the hyperbola that has these characteristics. Alright, number 16 is the last one. Focus, directrix. This is definitely a parabola. Let's make a sketch. Okay, the focus is at -3, -1. So 1, 2, 3, and -1. Okay, so there is the focus right there, -3, -1. The directrix is at y equals 5. Now y equals is automatically a horizontal line. So 1, 2, 3, 4, 5. So the directrix is a horizontal line at 5, like this. Okay, the vertex should be halfway between the directrix and the focus. Okay, so it's going to be lined up with the focus at -3. Let's see, these are 6 apart. 5 up, 1 down. That's 6 apart. So if I go down 3, that should be right in the middle. So if my vertex was here, that would work. So this would be -3, 2. That's my vertex. Alright, if I go from 2 to 5, that's 3. From 2 to -1, that's also 3. So it's right in the middle. So if that's my vertex, that tells me a couple of things. First of all, we're dealing with a parabola that is opening down. It's a vertical parabola. So when I have a vertical parabola, I know that the x part of the equation is going to be squared. So my model is x minus h squared is equal to 4p times y minus k not squared. If it was sideways, the y minus k part would be the squared part. Also, since I know the vertex, this is my h and my k that shows up here and here. So the signs will change. So I will have x plus 3 squared is equal to 4p times y minus 2. Whoa! Did I put squared just now? Oh my goodness. Must be getting tired. Only the left side is squared. The 4p side over here, not squared. Do not square this. Okay, that's a big mistake. So I have 4p times y minus 2 not squared. So I'm almost done. All I need is the p value. Well, take a look. The p value is the distance from the vertex to the focus, all right, including the direction. So we already sort of talked about this. This is 3. But because it's going down from the vertex to the focus, p is negative 3. So if I take my negative 3 and substitute it in right there, then I'm going to have x plus 3 squared is equal to negative 12 times y minus 2 not squared. Oh my goodness. So this is it. This is the standard form equation of the parabola with these characteristics. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.